Today's lecture will comprise of a phenomena known as total internal reflection. A good quality mirror may reflect more than 90% of the light that falls on it. You know, a mirror's phenomenon is associated with reflection, but absorb the rest. That means 90% will be reflected and some percentage, say approximately 10% will be absorbed. But it would be useful to have a mirror that reflects all of the light that falls on it, isn't it? Why? Because it will give you a very bright image. More reflection, more is the brightness of the image. Interestingly, we can produce total in reflection using an aspect of refraction. Now, children, whenever light falls on any surface, then it not only passes through undergoing refraction, but some part of the light gets reflected also. That is, when light hits a surface, some of it may pass through and get bent, that is, refract, and some of it may bounce back, that is, reflect. So you can see in this diagram that the incident ray that is falling over here, part of the light is got refracted and some part of the light has got reflected. Now, when light travels from a denser medium, example glass, to a less dense medium, example air, the speed of the light increases. The light refracts away from the normal. The angle of refraction is greater than the angle of incidence. So, here you can observe that the light is incident in glass, that is the denser medium, and it is moving into air, which is the rarer medium. This is the angle of incidence. This is angle of refraction. Since light is bent away from the normal, so angle of refraction R is greater than angle of incidence. Now, if the angle of incidence is increased, the angle of refraction also increases. So that means over here, if we keep on increasing the value of I, then R will also continuously increase. At a certain angle of incidence, the light will refract at 90 degrees and travel along the boundary between the two media. That means when we were continuously increasing the value of I, the value of R was also increasing. So a stage will come at where R will become 90 degree. This is the value of R and it will become 90 degree. That is, at a particular angle of incidence, the light will travel along the boundary between the two media. This angle of incidence in the denser medium, because we had taken the situation when the light is traveling from denser medium to rarer medium, when the angle of refraction is 90 degree is known as critical angle. So this particular angle where we have represented here as theta c, you can also say IC, is the critical angle when angle of refraction is equal to 90 degrees. Now, if the angle of incidence is increased further so that it is greater than the critical angle, the light will be totally internally reflected. What it means is then when you had I equal to IC, then R was 90 degree. Obviously, when your I is greater than IC, then R will be greater than 90 degrees. So, the light will come back in the same medium. And when light comes back in the same medium, you say that reflection is taken place. So, here we use the word that it gets totally internally reflected. That means no light is going to be in this particular medium. So, if the angle of incidence is bigger than this critical angle, the refracted ray will not emerge from the medium, but will be reflected back into the medium. And this phenomena is called total internal reflection. So here remember that whenever angle of incidence is greater than the critical angle, then obviously R has to be greater than 90. So here the total internal reflection will take place. And obviously when reflection has taken place, then this angle of incidence and this angle of reflection will be equal. Now, what are the conditions required for total internal reflection to occur? We can call total internal reflection in short TIR. The first condition is the light must be traveling from a more dense medium into a less dense medium. It can be any medium. Here I have written glass to air. It can be any denser medium to rarer medium, but the light has to travel from denser to rarer medium only. The angle of incidence should be greater than the critical angle for the phenomena of total internal reflection to occur. Now let's see what is the relation between refractive index and critical angle. So over here we have taken a situation, let's say this is a medium B which is optically denser and this is medium A which is optically rarer. Now light is incident in this medium at an angle C and R is 90 degree. That means the critical angle or angle of incidence is denoted over here as C. Now light is traveling from denser medium B to medium A. So how do we find the refractive index? It will be B mu A. That means refractive index of rarer medium with respect to the denser medium will be written as sine I upon sine R. This is the usual formula for finding the refractive index. Now let's substitute the value. Now here I is C and R is 90 degree. So we get refractive index B mu A equal to sine C upon sine 90. Now, you all know C is the critical angle and angle of refraction is 90. Sine 90. The value of sine 90 is equal to 1. So, over here, you will get this as sine C upon 1. And using the principle of reversibility, you will get A mu B equivalent to 1 upon sine C. That means the refractive index of denser medium is equal to 1 upon sine of critical angle. Now, for your information, or you may remember this, that critical angle for glass is 42 degrees and critical angle for water is 48 degrees. Now, let's see what are the factors which affect the critical angle. First, the color or wavelength of light. and second, the temperature. Now, how does the color affect the critical angle? The critical angle increases with increase in wavelength of light. The critical angle for a pair of media is less for violet light and more for the red light. Effect of temperature. The critical angle increases with increase in temperature because on increasing the temperature of the medium, its refractive index also decreases. Now let's see what is a comparison between total internal reflection and reflection from a plane mirror. That means that we are using a word over here total and here reflection from a plane mirror. Total word I hope you have understood is used because the entire light is being reflected. Over here part of light is absorbed also. So first is it takes place only when light passes from a denser medium to a rarer medium, and that too at an angle of incidence greater than the critical angle for that pair of media. Reflection from a plane mirror, it takes place when light is incident on a plane mirror from any medium. It can be any medium and any angle of incidence. The phenomena of total internal reflection is only occurs when light travels from first denser to rarer medium and I is greater than IC. But reflection will occur in any medium when light is there in any medium and there can be any angle of incidence. Here, in total internal reflection, entire light is reflected, whereas in a regular reflection, only a part of light is reflected, while rest is refracted and absorbed. Now, since entire light is reflected, there is no loss of energy. The energy of the reflected ray, you can say, is same as that of incident ray. Since only a part of light is reflected, that means there is a loss of energy. The energy of reflected ray is less than that of the incident ray. Now children, since there is no loss of energy and all the light is reflected, so the image is much brighter and the brightness is permanent. The image is less bright and the brightness gradually decreases as the silvering on the mirror becomes old and rough. So these were the differences in the phenomenon of total internal reflection, which takes place when light travels from denser to rarer medium when angle of incidence is greater than critical angle, and a normal reflection which takes place in any medium at